So Unit 6 is going to be about polynomials. I think the first lesson will be, it's really just an opportunity to go back and kind of just make sure we're all on the same page. But I think you guys probably know how to do everything that's on this today already pretty well. So consider it nice that it's an easy day, though it may be a little dull. All right, so let's start off by talking about some vocabulary. A monomial. Let's see. A monomial, which can also be called a term, is a single algebraic expression that may consist of one or more of the following. It can have a constant known as a coefficient. So this would be considered a monomial. Mon means one, nomial means number, so that's one number, right? So it could be a constant, but it could also be a variable. That would be considered like a monomial. Those variables can have exponents. That's still considered a monomial. Okay? Those are all examples of monomials. Or it could be any combination of those things. So you could put all those things together. Like this would be a monomial. By putting together, I mean by multiplication. They're multiplied together. Okay? All right. So now that's a monomial. What's a polynomial? That's whenever you have two or more. Well, I guess it could technically be one or more monomials that are being added or subtracted together in some way. Okay, so technically that's technically a polynomial. It's just a special one called a monomial because there's only one. But if I put another one next to it and add them, well, now that's not a monomial anymore, but it's still a polynomial. So anytime you have one or more monomials being added or subtracted together, that would be a polynomial of some kind. Now there are special kinds of them. They get names because they're pretty common. A binomial would consist of two terms. So like, for instance, 3x minus 5. There's two monomials there being combined with a minus sign. That would be a binomial. And a trinomial consists of three terms, just like the one I just had up a second ago. I'll just put it back up there. I don't know if it's the same exact one, but that's a trinomial. It's got three terms being added or subtracted together. Let's see. So we're going to do two things with polynomials today. We're going to add, and we're also going to multiply. And once again, I think this is stuff you guys probably already know pretty well. I could probably give you the worksheet, and you probably just get it anyway. But just in case, I'm going to go through it, and we'll see what we can do. So how do you add monomials? You can only add them if they are like terms, and like terms have the same variables with the same exponents. They're the same variables with the same exponents. So, for example, let's say 5x and 3x squared. These are not like terms. Because even though they have the same variable, x's, one has a power of 2 and the other one doesn't. So that's not like terms. Okay. Let's do another one. Like, let's say I had 5x and 3y. Now they've got the same exponent on them. Like there's a 1 here and a 1 here, but they don't have the same variable. So that's not like terms. Okay. They would have to have the same variable with the same exponent to be considered like terms. So those are like terms, or maybe if they both had squares, they could be like terms. Okay. So we have to be able to identify which ones are like terms, because those ones we can add them together. We can add them together. So we've got some examples here of things that are like terms and things that are not like terms. Does anybody need that up there a little longer? I'll pause for a sec. Okay. So to add or subtract, to add two like terms, you either add or subtract the coefficients. The variable and exponent don't change. So for instance, if I had 6x squared and negative 8x squared, first of all, I have to make sure they're like terms. They are. They both have an x to the second power. And all you do to combine those, if you wanted to say add them together, is you just add the 6 and the negative 8 together. 6 and negative 8 makes negative 2, but the variable and exponent don't change. So that's how you combine like terms. Okay? So we're going to do some exercises with that now. Can I delete? All right, so let's take a look at some practice problems here. Would you guys go ahead and write down this, please? I'll give you a sec. Okay. Let's make a little change to this, okay? I'm going to make this one a plus. Would you guys do that as well? Make that a plus. So what I have here is I've got three trinomials. There's a trinomial, there's a trinomial, and there's a trinomial. We're adding the first two and we're subtracting the last trinomial. Okay? So anytime you're adding polynomials, you can pretty much just get rid of the parentheses. You don't need them. So I'm going to get rid of those parentheses. But if you're subtracting a polynomial, before you get rid of the parentheses, you need to distribute the minus all the way through. And what that's going to do is it's going to change all their signs. So the 4b becomes a negative 4b cubed. The 5 becomes a plus 5 now, and so on. Right? And what we want to do is we want to just combine the like terms. That's it. So right here I have a cube. So I'm looking for a b to the third power. We've got a couple of those up here. I see one here. And as I identified, I'm going to include the minus sign that's in front of it because that's part of our consideration there. And then this one also. And we're going to put those together. So I've got 6, minus 8, and minus 4. I think if we put all three of those together, we're going to get negative 6, right? All right. So next, we just keep going down the list here. We've got the negative 4b to the fourth. I see a few other b to the fourths. There's one. Yep, just two. So we'll put those together. Negative 4 and 3 makes negative 1. So that would be b to the fourth. Once again, all we're doing is combining the coefficients, not the exponents. Oh, I miswrote that one. Thank you, Josh. So over here, this was supposed to be a 4. Josh has pointed out there, so I need to correct that. So this was supposed to be a 4. And since that was a 4, I need to include that here. So we have negative 4 and 3 is negative 1 minus 4 is negative 5 b to the fourth. Thank you, Josh. And then the last one here, yeah, we have these. These are called constants. It's still considered a monomial, but constants don't have a variable with them. And so those are like terms because they do have the same variable. Their variable that they have in common is none. So we'll just put those together. That would be negative 1 and negative 1 and 5 is going to be 3. Now just as a side note, this is technically the right answer, but when you're dealing with polynomials, typically what we'll do is we'll put them in descending order, which is where you start with the term that has the biggest power and you work your way down. So this term has the biggest power, so I'm going to put that first. And then negative 6b cubed has the next biggest power, so that will come second, and then 3. So the constant usually comes last. Now you wouldn't be wrong, like if I were giving you a written test and you wrote this, I would still give you full credit, but on a multiple choice test, that's how they're going to have it written, is in that order. Okay? That's what we call descending order. let's write that down. Descending order. Highest exponent to lowest. So there's the second one here is a student practice, so see how you guys do with it. I will have you guys leave it as a minus and a minus this time, okay? I just wanted to make the point that if you have a plus, you don't need to distribute a negative, but if you have a minus, you do. So go ahead and work on this one, and then we'll move on. Get it? So there is the answer. Let me know if you guys need anything. So we're going to move on to multiplication now. With multiplication, so let's say I have 5x and 3x squared. They do not have to be like terms to be multiplied, okay? So what you do when you're multiplying monomials is you multiply the coefficients together like you normally would, like 5 times 3 is 15. And then what you're going to do is you're going to add the exponents of the variables. So this x, since it doesn't have an exponent there, we're going to put a 1 there. And so you add the 1 plus 2, and you get 3. Okay, so that's multiplying. So that is different, right, than adding and subtracting. There you go. So let's go ahead and take a look at some examples there. All right, so for this one here, we're multiplying. We're multiplying a monomial by a trinomial. I'll wait for you guys to write it down. All right, so to multiply these, basically what you need to do is you need to multiply every term on one polynomial by every term on the other one. For this one, it's just as simple as distributing. Okay, so I'm going to multiply here, and then I'm going to multiply here, and I'll be done. Now, if I start having like a binomial with a trinomial, it gets a little bit more complicated. But for now, we're just going to distribute. So let's do this one first. I want to do 2v to the 5th power times 6v to the 2nd. So I multiply the coefficients together. That's 12. And I add their exponents. 5 and 2 makes 7. Next one, I'm going to multiply the 2v to the 5th by the 4v now. So 2 times 4 is 8. And v to the 5th times v to the 1st is v to the 6th. And then finally we have 2v is going to multiply by 5. 2 times 5 is 10. And since there's no v's on the 5, the v will stay the same as the one on the outside. There's just going to be 5. And that's it. Okay. So why don't you guys try that guy there. So that's multiplying a monomial by a trinomial. It's basically just distribution when you're multiplying a monomial. But the idea is you want to multiply every term in this one by every term in this one. And you'll see that that's going to give us a challenge here. On the next set here, we've got these two. Now, different teachers teach this differently. But go ahead and write this down. Some teachers teach it using the box method. I'm sure some of you guys have heard that. How many of you guys use the box method? That's fine. That'll work. Some teachers use FOIL. Does anybody use FOIL? FOIL works fine. You show less work that way, but it could be faster. I like the box because it does show all your work. Also, it connects nicely with something else we're going to learn later, factoring. So, but you're welcome to use FOIL if you like. All right. So I need to multiply every term here by every term here. And so I need to multiply the 5x times both of these, and I need to multiply the 6 times both of these, and that will be all the possible combinations I can have. Now, like I said, some teachers use FOIL to organize that work, make sure you got everything covered. I like to use the box. So here's how I do the box. There's 2 terms here. I'm going to write 2 terms. And there's 2 terms here. I'm just doing this for notes. You don't usually have to write this when you solve the problem, but The reason why I want to start by identifying how many there are is because that tells you how big your box needs to be. My box needs to be a 2 by 2 box. It needs to be 2 tall and 2 wide. In other words, 4 squares. Right? You're going to put one of your binomials along the top. Keep the sign with the number that it's in front of. So I'm going to put the plus with the 6 there. And then the other binomial is going to go down the side. And this is just a nice way to make sure that we get every piece multiplied together that we're supposed to. So it's kind of like a Punnett square in biology when you're doing those genetic thingies that you guys do in there. To find out what this square is, we're going to multiply the one above it and the one to the left of it. So 7x times 5x. 7 times 5 is 35. X times x, that's 1 plus 1, which is 2 for an exponent, so 35x squared. To find your next box, the one above it is 6, the one to the left is 7x, so I'm multiplying these two together to get that box. That would be 42x. To get this box, the one above is 5x, the one to the left is negative 4. If I multiply those together, I get negative 20x. And then finally, the last box is the one up here, and the one to the left, which is negative 24. So we get 4 answers as a result there. Now, I'm going to put them in descending order. 35x squared plus 42x minus 20x minus 24. But a lot of times when you do this, there's going to be some like terms. You guys see the like terms there? The 42 and the 20. So if I do 42 take away 20, now remember, now we're switching back to adding. We're not multiplying anymore, so the rules are different. With adding, all you do is you combine the coefficients. 42 take away 20 is 22, but you keep the x the same. So that's a different rule than the adding stuff. So to fill in the box over here, we did multiplication. But to simplify here, we did addition. So we've got to keep those rules separate. And there's our final answer. Now, just so you guys know, I don't usually show this step right here. I just did that for teaching it this time around. But usually what I'll do is I'll just write this, the first one. I know this is going to be the last one. The middle one's going to be these two combined, so I just do that in my head, and I save myself the trouble of having to write an extra step. So you guys could do it however you want, but there you go. So that's the box method. I started off by looking at how many terms I have. 2 and 2. That tells me how big my box is. Multiply to fill in the box. Combine any like terms, and you're good to go. All right, so let's see here. Let's do another one here. How big does my box need to be this time? 2 by 3. You could draw it in 2 different ways. You could, well, first of all, before I draw it, why is it 2 by 3? This one has 2 terms. This one has 3 terms. And once again, you guys don't have to write this when you're doing your homework. I'm just doing that for notes. 2 by 3. So you could draw your box like this. 2 by 3, or you could draw your box like this. It doesn't matter. You should end up with the same answer in the end. I like the horizontal one, but it's your call. So I'm going to make a 2 by 3 box. Another reason why I like the box better than FOIL is that FOIL only works for 2 binomials. It doesn't work for this. But the idea is the same. You're really just multiplying every term over here by every term in here. It's just the box organizes things. It also helps line up your like terms a lot. So now I don't have a choice of where to put them. Last time when we had the box method, it didn't matter which one you put on the top, which one you put on the side, but here it does matter. The one that has 2 terms, I have to put it down the side here because that's where the 2 terms are. And the one that has 3 terms, I've got to put it along the top. And then we're just going to fill it in. I'm going to fill it in a little quick. Might be quicker than you can calculate, but that's okay. We've already practiced that, so for now you can just write it down. You'll get a chance to practice it in a minute. Now at this point, I really don't want to write all 6 of those answers out in descending order, so I'm not going to. I'm just going to take them out and combine them as I go. So the biggest power is here, so I'm going to write that one first, 20n cubed. Next biggest one is the squares, and you'll notice another cool feature about the box, not always, but usually, they're going to be diagonal to each other. So my 2 squares are there, so those are like terms. They have the same variable with the same exponent, so I can add those together. Now remember, we're not multiplying, we're adding, so the rules are just combine the coefficients, but don't change the variable or power. So 16 and 10 is 26n squared. Another one there, 33n. 8 and 25 makes 33. And then finally 20. All right. I'll leave that up there for a second, then I'll put up your last 2 problems for the day. I think that'll be it, if I'm not mistaken. It'll be a quick day. What time do we get out of here? 2:35. Hey, what's up, Tom? Sure. I'm going to put the answers up also at the same time, so you could check your work. But there's 2 for you guys. So, you know, if you feel like number 7's too easy, and you're thinking, I just want to make sure I know how to do number 8, then just do number 8. If you feel like, okay, I probably need to review this, then maybe start with number 7. But there you guys go. And I'll just kind of walk around and check notes. And if you need help, let me know. Squish my guys.